Hola! Welcome to the week number 7, and this will be our topic, and it is under basic lighting analysis. Okay, first we need to know what will be the learning outcome of this topic. You need to perform the basic lighting analysis. After this session, you will know how to solve the Lumen method with 11 steps, and you will have a certain plate on solving or applying this concept. Before we proceed to the lighting design or the basic lighting analysis, you need to be familiar with the main terms. This will be the 4 terms that you need to be identified. First is the absorption, second is the brightness, luminous flux or lumens, and luminous intensity. Take note that brightness should be used only for non-quantitative references to physiological sensations and perceptions of light. Remember that brightness was formerly used as a synonym for the photometric term luminance, and incorrectly for the radiometric term, which is radiance. Now, as you can see, absorption is the dissipation of light within a surface or medium. So, the way of absorbing light. Brightness is an attribute of visual perception. Kato atong makitaan, kahayag. This is what we call brightness. Luminous flux is the measure of the total light producing power of the light source. This is the time when we will turn on the light. This is what we said in Bisaya is yaga sugaw. This is what we call what will be the brightness, or which means the proper terms is the lumens of the light source. So it is the amount of light leaving the source without regard to direction. So as an example, we have a typical 100 watt incandescent lamp, and it has about 1700 lumens. Remember that wattage is different from lumens. Okay, so you need to know the lumens of certain lamp. Sometimes it is indicated on some of the branded light bulbs. Okay, you can check the box. And the luminous flux rating is provided by the lamp manufacturers, and a listing of common lamp and lumen values can be found in the lamp matrix. The last is the luminous intensity. The luminous intensity is measured in candelas, and it is the strength of the light produced in a specific direction. So meaning, unsa ang yang kahayag naggihatag dito sa certain area, which is lamesa. For example, you are working on the table, plane, or surfaces, then you will say, di mo kay hayag ang lamesa ba eh? So it means this is the strength and intensity of the light produced on that location. Now let's proceed to the other main terms. Now, before we proceed, I forgot that the luminous intensity of an optical system is compiled graphically into diagrams known as candela or candle power distribution curves. So sometimes there's a certain way that you can say that will be the possible light shape of a lamp, like this. So you can assume that the light shape of the lamp is a circle. Sometimes it is a flower shape, oblong shape, and there's a luminous intensity table. So both polar and Cartesian graphs are used within the lighting industry for this purpose. So this information is also available in numeric tabular form, and this is very highly used on the illumination designs of the electrical engineering. Now let's proceed to the next slide. The lighting design, which is main terms, is the Batwing Distribution. This is what we call candle power distribution, which serves to reduce glare. So we will discuss about glare in the next slide. And veiling reflections by having its maximum output in a 30 degrees to 60 degree zone. So how do we understand that is we need to be identify the cutoff angle. So this is the angle at which a lamp is not directly visible in a reflector. So you can see in this part we have this lamp Then, the distribution of light is at the form of 90 degrees cutoff angle. So, makita ninyo asa yung kahayag lang. And it's shaped as 90 degrees. While this is commonly a wall lamp or wall sconces. And it has 66% cutoff angle. While having a bollard or street lamp, just like on the parks, there's a no cutoff angle because there's no angle distribution. The light is distributed along the sphere. Now, let's be familiar with the glare. The glare is the sensation produced by luminance, just like at the background of this slide. So, there's a glare of all lights or street lamps, but it is sufficiently greater than the luminance to which the eyes are adapted to cause annoyance, discomfort, or loss in visual performance and visibility. Just like if you are driving and nakikasugat, naka-fog light siya, and that is what we call term glare because it can be cause annoyance, discomfort of you driving, sugat kasi ha. So that is one of the common mistakes in engineering or electrical lighting design. So there is two glares. Number one is a direct glare. So direct glare is usually associated with bright areas such as luminaires, ceilings, and windows, which are outside the visual task or region being viewed. But the discomfort glare with the keyword producing discomfort, so it does not necessarily interfere with visual performance of visibility. Then there's the other terms. We have luminance, radiance, reflected glare, radiance, reflection, refraction. This is common on the physics, sphere illumination, and candle power. Radiance and spectral radiance, they are used to characterize both emission from diffused sources and reflection from diffused surfaces. So we have two. So the SI unit of radiance is watts per steradian per square meter. So I'm just only giving you information about this, but this is not part on solving the lumen method. So under your course, this is just an additional information. And the reflected glare, it is usually associated with reflections from within a visual task or areas in close proximity to the region being viewed. So reflections of high luminance. Okay. Now, remember that we are in engineering and architectural courses. We need to have a unit of measurements. So these are the 5 common unit of measurements. We have candela. So the unit of measurement of luminous intensity of a light source in each direction. While the foot candle is the unit of illuminance when the foot is taken as the unit of length. So it is the illuminance on a surface 1 square foot in area in which there is a uniformly distributed flux of 1 lumen. Or certainly, this foot candle can be used if you are using the English system of measurement. Lumen is the unit of luminous flux. It is the luminous flux. So it is earlier mentioned on the slide 3, lumens. So next is the lux, the metric unit of illuminance. So if we have English unit, foot candle, we have also the SI unit for illuminance, which is lux. So 1 lux is 1 lumen per square meter, while the other side is 1 foot candle with 1 lumen per square foot. Okay, this is the different measurement. Then the last is the foot Lambert. It is a unit of luminance of a perfectly diffusing, surfacing, emitting, or reflecting light at a rate of 1 lumen per square foot. Okay, before we will have, since we have formula, we have computations here, we need to also consider constants or sometimes coefficients and factors. The number one for that is the coefficient of utilization, where it discuss about the ratio of the luminous flux from a luminaire calculated received on the work plane to the luminous flux emitted by the luminaire's lamp alone, meaning unsang yang iyahang luminous flux from the light itself, from the lamp itself to the working surfaces. Okay? So in Bisaya, gikan sa suga padulong sa imuhang lamisa. So we need a coefficient of utilization. The next one is the color rendering index. It is the measure of the degrees of the color shifting undergo when illuminated with the light source as compared with the color of those same objects when illuminated by reference source. Remember, assume that this is the original. The original color, as you can see on your naked eye, that the color of the strawberry is a light red. When it is ibot nga nimo sa source of light, then it has a higher color temperature of the strawberry, and it's what we call color rendering index. So termly, we call it as a high CRI and low CRI at the right side. So if you're using Adobe Photoshop or any Photoshop software, then you're very familiar with this CRI term. So aside from these two, we have also three coefficient and factors. Number one is the color temperature. So for civil engineers, electrical engineers, or the architects, they're very familiar with this. So if they are giving some specifications or materials to their client, so we need to know when to use what type of color temperature of bulb do you want to install on that certain area. In this is what we call, we have three types. Number one is the daylight, cool white, and warm white. So muna siya, from blue to white, from yellow to lighter yellow, then lighter yellow to dark yellow. So you can see in this picture, this is the application of three color temperature, which is under Kelvin degrees. Then sometimes if you're buying high price lamps, just like using Philips, GE, and some local brands, some box they are using or labeling them that they are using daylight, cool light, and warm white bulb. So you must make sure that you are buying the proper one or the right one. Next is the contrast, the difference in brightness of an object and its background. Okay, so you're very familiar with this since we are using some of Android app, so editing some of our pictures for posting in Instagram and Facebook. Then the next one is the lamp efficacy. So the ratio of lumens produced by a lamp to the watts consumed. It is expressed as lumens per watt. That is why some lamps are labeled depending on what is the wattage. But to term for that, you need also to understand the lamp efficacy. And now you have the basic formula for this. So you need to divide the lumens indicated on the box divided by the wattage specification on bulb or lamp you using it. Next is the lighting design coefficient factors. We consider as also the LLD, the LDD, the luminar dirt depreciation, the luminar efficiency, and the maintenance factor. The LLF is a factor used in calculating illuminance after a given period of time and under given conditions. So it is considered temperature and voltage variations. Dirt accumulation on luminaires and room surfaces. Diri na siya mosulod katong ang imuang gipalit na suga for how many years mangluspad na ang iyang kahayag, nang luspad siya kay tungod gisudlan siya og mga lamok or any bugs. And the other one is naabugan, that is why dili na kaya siya hayag. But this is what we call lamp lumen depreciation. And sometimes if you're using lamps for outdoor usage, then if it is exposed on rain, sunlights, or any circumstances, it is under with the LLD. And this LLD was formerly called maintenance factor. So it is a maintenance factor indicated here in the definitions at the lower part. It is also called the light loss factor. So we have three common. So light loss factor, lamp lumen depreciation, and maintenance factor, they all the same. And they generally, light loss factors are divided into two groups. Okay, so sorry, two groups just like formerly called recoverable. So remember that some lamps are recoverable, so you can clean it. You can also replace the lamp, or that is what we call relamping. And the last one is if the fixture itself, the lamp itself, is cannot be used or recycled and it is under non-recoverable part. Now we can